Pay attention to how they burn, how long they burn, and the smoke that you see coming off of them. Here's A. It's gonna be difficult, huh? There we go. Yeah. So what do you know about the smoke coming off of A?
Puffs of dark gray smoke.
Yeah, so we got that dark, I didn't call it black smoke. And then do we have any smoke coming off of B, or did we have any smoke coming off of B?
It was wider.
Yeah, so it was not, if there was smoke, it wasn't nearly as dark as the smoke from A.
But not a lot.
Not a lot, yeah. And then B burned out a lot faster. And I lit it second. A's still burning. Took A a minute to catch, which I haven't had issues with. But yeah, so yeah, there it went. Yeah, it took a minute to catch. What happened to it like before it actually caught fire? You see what it kind of did? Kind of like melted?
Crumbled.
Yeah, like shrunk. Shrunk up before it melted, or before it caught fire. Yeah. So A burned longer and had black smoke and kind of like melted. B it burned much cleaner and it didn't burn as long. That's it for was this number 4? For the water test, we're going to drop them in and we're looking for one of them to dissolve. One of them is going to dissolve in the water, but it does take a little bit of time. So I'm going to go ahead and drop them in. Make sure they're coated. Okay, and we'll give that some time and we will check in on it back here in a minute. So checking on the water, you can see here that the natural polymer is starting to dissolve. It takes longer though. The water is definitely not as quick as the acetone. Okay, but it is dissolving. Okay, so in the water, that's test number 5. Nothing happened to A and B dissolved. So, and again, we're looking for one of them to dissolve. So I'm going to go ahead and put B in, and then we'll go ahead and put A in. So, in the acetone, the synthetic polymer dissolved, and it dissolved pretty quickly. This is the test with acetone. Yeah, number 6. Okay, acetone is a remover. So a lot of times, ladies, you're probably familiar with more with acetone because it's in a lot of nail polish removers. It is also used to remove grease and grime, residue. It's really good at eating away at those polymer, those synthetic polymer compounds. Okay, you want to be careful with it though. If you were using it at home and you had some on like your countertop or something, it can strip the finish right off. It can eat through it, so you want to be careful with it, as you can see. So it's not doing anything to the natural polymer. The natural polymer is fine. So we fill a gallon bag for each that have the same volume, and we're going to mass them and see with the same volume, do they have the same mass or a different mass? So it'll tell us which ones are more dense, actually. So for A, here's A. .1 for A, 24.1 grams. For A. Then for B, Do you think B is going to be heavier, lighter, or about the same? Heavier?
Lighter.
Lighter? Anyone say close to the same? All right, let's see. $46.5 grams. 46.5 grams. Twice the mass for B. That may come into factor when you are, if you're shipping something by weight. You know, if you have to use a lot of packing peanuts, that might cost more if you use the natural versus the synthetic. But as we see, if we just saw them burn, if you haven't guessed already, A is going to be toxic, B is non-toxic. The synthetic one is toxic and the natural one is non-toxic. So even though the first one has a lower weight, the toxicity might scare customers away. They don't want to use that because it's toxic. But it might be cheaper to use it. So you kind of have to weigh out your pocketbook with your conscience, and that's not always easy to do as a consumer. You know, what's better for the environment and what's better for me money-wise. Like the synthetic one is made from polystyrene. The name brand is styrofoam, but the chemical name is polystyrene. And that's made from petroleum products. So that's the oil that we get out of the ground. We can break that down into different products we can use, and one of them is styrofoam or polystyrene. And then B is made from, it's starch-based, so it's actually made from cornstarch. So then for number 9, we're saying, is it renewable or non-renewable? Okay. Substance A, made from oil from the ground, is that renewable or non-renewable? Non-renewable. So non-renewable means that we can't replenish it before we're going to run out of it. And packing peanut B is made from cornstarch, so it's made from corn. Is that renewable or non-renewable? That's renewable. We can grow corn every year. So the rest of the questions have a link that you can click on. And then the answer to the question is somewhere in that article that you've clicked on. You're going to have to read around a little bit.